Hi everyone, my name is Diana Garcia and today I'll be working on problem 7 from homework number 3. And for this problem, we have to find the general solution by using the method of integrating factors. So first, we must isolate dy over dt by dividing 5t throughout the whole differential equation. So now we see that we can cancel out the 5t here, and on the right side we're left with t squared over t squared over 5 because the t cancels out from the denominator. So to rewrite it, we'll get dy over dt plus 1 over 5t y equals to t squared over 5. So in the method of integrating factors, we must find what p of t is. In order to find p of t, we see what the value is before the y. So here it's 1 over 5t. So let me just write p of t equals to 1 over 5t. And now we solve for our mu of t. So our mu of t would be e to the power of the integral of 1 over 5t. And when we try to solve for the integral of 1 over 5t, we can bring out the 1 over 5 because it's our constant, and we're left with the integral of 1 over t, which we know 1 over t is ln of t. The integral of 1 over t is ln of t, so we're left with 1 over 5 ln of t. So now we plug this back into our mu of t. So e to the 1 over 5 ln of t, and this can just be written as t to the 1 over 5. So this is our mu of t. So now we must multiply our mu of t throughout the differential equation. So t 1 over 5 multiplied by dy over dt plus 1 over 5 ty equals to t squared over 5 multiplied by t 1 over 5. Okay, so now that we have that, we can distribute. So we have t 1 over 5 dy over dt plus t 1 over 5 over 5t equals to t squared times t 1 over 5 t squared times t 1 over 5 over 5. So now we simplify. Oh, I'm sorry, and I missed the y here. And now we must simplify. So we're left with, we see that we can add these exponents, and when you add them you get 2.2. And here we subtract the exponents, and we have, so let me just rewrite this. Or dt in simple plus 1 over 5t.8. That's because you do 1 over 5 minus t. So 1 over 5 minus 1. Y equals to t 2.2 over 5. So now that we have that there, I'm sorry, I got a little confused at first. So now we find the integral on both sides. Okay, so now that we have that, when we find the integral, we have d over dt, t to 1 over 5 times y dt, let me not forget, I can do this, dt equals to the integral of t 2.2 over 5. And the integral of t 2.2 over 5, let's just do that on the side. So we bring out the 1 over 5, integral of t 2.2. So the integral of t of 2.2, we know that we must add a 1 on the from the exponent and divide it by whatever our new exponent is. So it'll be t 3.2 over 3.2. So that's our integral for the right side. And then here we get t 1 over 5y equals to t 3.2 over 3.2 times, and we can't forget the 1 over 5 that we had here, 1 over 5. And that's t 1 over 5 y equals to t 3.2 over 16. Now we must isolate y by dividing t to the power of 1 over 5. So we're left with, I'm sorry, I forgot the constant here on the right side. Always remember your constant. So we divide by t 1 over 5 on both sides, and we're left with y of t equals to t 3.2 over 16 plus c over t 1 over 5.